Hello, my dear students. Welcome to the class. In our previous class, we have started with the chapter called Motion in a Straight Line, correct? Okay, and we have reached to the concept of path length and displacement. So, I hope you understood. Path length is nothing but distance traveled by the body, or else I can call path length is equal to distance, total distance, correct? Whereas displacement is nothing but change in the position of the object. Now, what I want to speak about is the term called speed, correct? Now, what I want to speak about the speed. What do you mean by speed? Speed is nothing but distance traveled by the body in time, or else I'll call it as rate of change of distance is nothing but speed. Speed is nothing but rate of change of distance. Or I'll call as speed is nothing but distance traveled by a body to the in the given time interval. So I can say that rate of change of path length or displacement, distance, both are same. Path length traveled by the body with respect to time. What is speed? Speed is nothing but rate of change of path length or rate of change of distance traveled by the body with respect to time. So when I speak about the speed is equal to, I can write in formula kind as distance by time. Distance by time is nothing but speed. When you write divide by time, I will say that rate of change of word I can use, because as the time changes, for the change in the time interval, there will be change in the distance. Understood? So rate of, if anywhere you divide by time, we start with the word called rate of change of distance, or rate of change of path length traveled by the body with respect to time is nothing but speed. And its unit is distance of unit of the distance is meter, time is seconds, meter per second is the SI unit of speed. Then what is the dimensional formula? M to the power 0, L to the power 1, T to the power minus 1. This is a dimensional formula for speed. Speed, when we calculate, we don't see the direction. We see only the magnitude. So, speed is a scalar quantity. Scalar quantity. It has only magnitude and no direction. Understood? Now I want to speak about the velocity. What do you mean by velocity? Velocity is nothing but rate of change of displacement with respect to time. What is it? Rate of change of displacement with respect to time. That means I can write velocity is equal to displacement by time. These are the basic concepts which you have learnt in your high school, correct? So velocity is equal to displacement by time. What is the unit of displacement? Unit of displacement is meter itself. Time is seconds, s to the power minus 1, because divide by time it is. So SI unit of time, SI unit of speed and velocity is one and the same. What is the dimensional formula? M to the power 0, L to the power 1, T to the power minus 1. This is dimensional formula for velocity. But when we measure the velocity, we see the direction. Whether the body is moving in X direction, Y direction. Why? Because see, displacement, it is nothing but change in the position of the object in a particular direction. So, when we calculate displacement in terms of direction, then velocity is also in terms of direction itself we will calculate with the direction itself. So, it is a vector quantity. It is a vector quantity. It has both magnitude and direction. Understood? It has both magnitude and direction. See, one concept I think I did not mention over there. Just a note. Make a note in your notes. We wrote path length is nothing but distance, correct? So path length or distance. What is the unit? SI unit? Meter. Meter is the SI unit. Then what is the dimensional formula for path length or distance? M to the power 0, L to the power 1, T to the power 0. Then for displacement. What is the unit? Again, unit of the displacement is meter. And dimensional formula is M to the power 0, L to the power 1, T to the power 0. This was left out to explain. So please make a note of it. Okay. Please write this point in your notes. Shall I continue? So we spoke about the speed and velocity. Whenever you drive a vehicle, maybe two-wheeler or four-wheeler or three-wheeler also, what do we speak? What is the average speed or velocity? Correct? So we will speak about the speed. We don't speak about the velocity. If we say what is the average velocity, then we will have to consider the direction. If a person moves from this point to one more point and reach back to the same point, then maybe starts from one point and ends at the same point by moving in some other direction also, total displacement reached back to the same position. So therefore total displacement is 0. Then velocity, whatever he traveled is full of waste. Velocity is equal to 0. So whenever we speak about the vehicle, we speak about the speed. Average speed. Correct? Next. The next concept which I want to move for is average velocity or average speed. What do you mean by average speed? What do you mean by average velocity? Ratio of the displacement of the body to the time interval in which the displacement occurs. Average velocity is nothing but what? Or average speed is nothing but what? So I'll speak here because for me it is easy to write here. So I'll erase this. I'll write sentence over here itself. You don't do the same thing. After writing notes, don't rub and write once again there itself. I hope nobody will do that because however you are writing in a pen, correct? Okay. So speed, after that I am going to do the concept called average speed. What do you mean by average speed? Average speed is nothing but total path length travelled by a body. Total path length travelled by a body divided by total time interval during which it has moved. Total path length travelled by the body divided by total time taken. Correct? Total time taken or total time interval during which the body has moved. Okay? During which the body has or during which it has moved. Body already written, so it has moved. So whenever we speak about the average, we'll speak about the total distance by total time. So average speed is equal to total distance by total time taken. Whenever we speak about the total distance by total time taken, it is nothing but average speed. But only speed means it is the distance by time. Understood? So, define average speed means total path length traveled by the body divided by total time interval during which it has moved. Understood? But its SI unit, everything is same. SI unit is same. Dimensional formula is same. It is a scalar quantity. Understood? Next, average velocity. What do you mean by average velocity? Average velocity means displacement of the object divided by time interval during which it has moved, or it is defined as the ratio of the displacement of the body to the time interval in which the displacement occurs. So for me, easy sentence is displacement of the object divided by time interval. Displacement of the object divided by the time interval divided by the time interval. Correct? Divided by the time interval during which it has moved. This is nothing but velocity. So, average velocity. Average velocity. So, I can say average velocity is nothing but distance, total displacement by total time taken. Correct? Average velocity is equal to total displacement by total time taken, or displacement of the object divided by the time interval during which it has moved. It is also a vector quantity. Its unit is meter per second, and SI dimensional formula is m to the power 0, l to the power 1, t to the power minus 1. See, whenever we speak about this average velocity, how it is change in position by change in time interval. Correct? So when we write in terms of formula, how do we write is v is equal to change in the position, final position minus initial position by final time interval, time by initial the time taken by the body. So we write it as delta x by delta t. This is how we write a formula for velocity. V is equal to x2 minus x1 by t2 minus t1. Since here we are speaking about the average, we are going to put one underline. Actually, it is not underline, overline. Okay, so average velocity means v to the power 1 line. So I don't say power, overline I can say, is equal to change in position, no, displacement means. So x2 minus x1 divided by t2 minus t1 is equal to delta x by delta t. The difference is delta x. Here difference is delta t. This is a formula. This is a method of writing a formula for the velocity. Understood? Now what I want to speak about is about the instantaneous velocity. Do you know what is instantaneous velocity? Instantaneous velocity means at that particular instant, it is a velocity at that instant, correct? So how can I explain about the instantaneous velocity? It is the rate of change of position of the body at a particular instant of time. Correct? At a particular point on its path. Or it is a velocity at an instant and it is defined as rate of change of position with respect to an infinitesimally small time interval. So, what I said just now? Instantaneous velocity. Or instantaneous speed. What is instantaneous speed? It is the it is the speed at a time or speed at an instant, and it is defined as rate of change of, see, I'll write it so that it will be easy for your understanding purpose. Instantaneous speed, velocity. I'll speak about velocity first. Instantaneous velocity. At that particular instant, what was this velocity? Is nothing but instantaneous velocity. You're moving. At that particular instant, what is your velocity? That is nothing but instantaneous velocity. So whenever we define instantaneous velocity, we say it is a velocity at that instant, or it is a velocity at an instant it is a velocity at an instant, okay, and is defined as rate of change of position with respect to rate of change of position, rate of change of position or displacement, whatever it is, same, correct? Rate of change of position with respect to an infinitesimally small time interval, with respect to an infinitesimally small time interval. Infinitesimally small time interval means, infinitesimally means, what I want to say is, it is nothing but infinitesimally means very small time interval, means that particular time interval 150.6 second means such a small time interval it is. 0.6 seconds. That means infinitesimally small time interval. So I will say that it is nothing but instantaneous velocity. Instantaneous velocity means what? It is defined as rate of change of position with respect to infinitesimally small time interval. So that is nothing but a limit, correct? You have to see the limit, so that is time interval. So in equation format, we will write it as v is equal to limit as delta t tends to 0, such a small, it is not equal to 0, but it tends to 0 into delta x by delta t. You will learn about this limit when you go learn it in mathematics, more about it. Now limit means such a limit is there, that is very small time interval, but it is not equal to 0. It tends to become 0. So I will say limit as delta t tends to become 0, delta x by delta t is equal to instantaneous velocity. Understood? It is nothing but instantaneous velocity. So instantaneous speed means what? Instantaneous speed means it is nothing but rate of change of distance with respect to time or with respect to infinitesimally small time interval. So can you write on your own for instantaneous speed? For that, can you write your own definition? Yes, it is nothing but rate of change of distance with respect to an infinitesimal small time interval. Okay, fine. Next, what we are going to speak about is the uniform and non-uniform motion. We already spoke about uniform motion. Uniform motion means what? The change in position of the object, correct? That is, if the object is moving in a straight line, it should cover equal distance in equal intervals of time. If the equal distance in equal intervals of time is maintained, then it is nothing but uniform motion. If equal distance in equal intervals of time, if it is not maintained, then it is called as non-uniform motion. So uniform motion, I have spoken in the previous class. Now I am not going to write on the blackboard. You just make a point in your notes. Uniform motion means it is nothing but equal distance with equal intervals of time, whereas non-uniform motion means not equal displacement or distance traveled by the body in the equal intervals of time. So that is nothing but uniform, and about the non-uniform or equal covers equal distance in equal, it does not cover. If a body moving in a straight line, if it does not cover equal distance in equal intervals of time, then it is said to be non-uniform motion. Understood? So this is about the uniform and non-uniform motion. Now what I want to speak about is acceleration. Acceleration is nothing but what you say when you ride a bike or a vehicle. You accelerate, give acceleration, accelerate. That itself is your acceleration. That means, acceleration means what? You raise the accelerator. Accelerator is there, no? Give acceleration. What is that? Acceleration means nothing but, what is acceleration? Can you say? It is a rate of change of velocity with respect to time. Rate of change of velocity with respect to, you write it in the sentence, don't write WRT, with respect to time. Rate of change of velocity with respect to time is nothing but acceleration. So velocity should change with respect to time. Then what is average acceleration? Average acceleration means what? Average acceleration means what? Can you explain? That time we spoke about average velocity and average speed. Average acceleration means what? Change in velocity of the object divided by time interval in which the change takes place, correct? In which the change takes place is called average acceleration. What is average acceleration? Ratio of change in velocity to the time interval. So write down average acceleration, change in velocity of the object divided by time interval. Time interval. Divided by time interval in which the change takes place. Okay. Now, so when we speak about acceleration, A is equal to, it is given by the letter A. A is equal to acceleration. V, velocity, rate of change of velocity, correct, with respect to time. A is equal to V by T. Average acceleration means A with one line is equal to, with this is equal to what? V2 minus V1 by del T2 minus T1, or else delta V by delta T is nothing but average acceleration. Understood? Understood? What is the SI unit of acceleration? SI unit for acceleration is velocity, meter per second. Time, again it is second, means it becomes meter per second square. This is the SI unit of acceleration. What about the dimensional formula? M to the power 0, L to the power 1, T to the power minus 2. This is the dimensional formula for acceleration. Acceleration. So, what is instantaneous acceleration? Instantaneous acceleration is acceleration at that instant and is defined as rate of change of velocity with respect to time, but it is infinitesimally small time interval. Can you write on your own? Just like instantaneous velocity, can you write your own definition for instantaneous acceleration? What is instantaneous acceleration? It is nothing but it is an acceleration at an instant and is defined as, what is instantaneous acceleration? It is an acceleration at an instant and is defined as rate of change of velocity with respect to infinitesimal small time interval. Can write, no? I hope you will write, correct? So how will I write instantaneous acceleration? I'll write it. Please write it properly. It is an acceleration at an instant and is defined as rate of change of velocity with respect to an infinitesimal small time interval. So A is equal to limit as time tends to 0, delta V by delta T is equal to dx by dt. dV by dt. In terms of differentiation, if you write, it is dV by dt. That time you had written one expression for velocity. Do you remember? There only, if you want, you can write one point. That is V is equal to limit as delta T tends to 0. You have wrote. Correct? You wrote it like this. And delta X by delta T something you wrote. Correct? Am I right? There only you can write dx by dt. In terms of differentiation, when we speak, we can write like this. That's all. Okay? Fine. Just for your knowledge, I have written it is dv by dt. So this is for acceleration, instantaneous acceleration. Shall I move further? I need your help.